And then there were 3. Sunspot groups, that is. Welcome to the Daily Space Weather. Little bit of an uptick showing up here in the closest star. Let's show some more spectacular imagery. This is a composite from the SDO. And here are those same wavelengths zoomed out to a full disk view. And we've got sunspots up here, over here, and down here. The most interesting, they're beta-gamma class. So check out the magnetic fields. Here's the colorized magnetogram also from the SDO. You can see this group forming up here. Beta class, beta class, beta class. All 3 groups. Here's 1600 and 1700 angstroms, northern hemisphere portion. And here's sunspot 2871, the star of the star currently. Expect to see lots of videos about this one. Here's a northern hemisphere in yet another set of wavelengths. This is 304 and 193 angstroms. Ionized helium and iron. And you can see some filamentary reorientation and ejection happening here from the southern hemisphere. Not bad. Here's a close-up of 2871. We've got this great filament structure showing up here, so we made sure we optimized the wavelengths. And let's blast through a whole bunch of more data here. 75, I believe, is the radio flux number now. Having only come up a little bit despite 3 sunspot groups, so expect the radio flux to come up precipitously and promptly. Here's a 1-year chart of the radio flux. The black line is what we're talking about, the 10.7 centimeter radio flux emitted from the upper chromosphere and lower corona. Next, let's check out the Space Weather Enthusiast dashboard, make sure it's refreshed. Pretty uneventful stuff going on here. No geomagnetic storms forecasted at the moment here. And I'm expecting some geomagnetic unrest someplace around September 22nd, as there's a CME headed our way. I don't know how they missed it. I don't know how they found one with the last non-event, but anyway, let's continue on here and talk seismicity. And there's certainly been an uptick in the interest in seismicity with the eruption of La Palma volcano in the Canary Islands, the possibility of a mega tsunami. It could cause 300-foot waves on Africa, and waves could go 12 miles inland in the east coast of the U.S., we believe. I find it unlikely. Let's continue on. To check the USGS list here, there was a deep quake in Indonesia. It was only a 4.4 magnitude. Shout out to all of our viewers who felt earthquakes. I never have, despite being in several. Dominican Republic saw a deep quake there at a 4.3 magnitude. We barely even saw a 5 magnitude quake here over the past 24 hours. Fiji saw a 556 kilometer deep 4.5 though. And just recently, a 4.4 at nearly 600 kilometers depth. Some deep quakes, no big quakes. And if you haven't heard this story, you'll definitely hear it if you're on YouTube or wherever you are, about the volcano on the La Palma, the Isle of La Palma, has erupted in a spectacular fashion, causing evacuations and raising the possibilities that a landslip type tsunami could occur if a large portion of the island slides into the ocean. And there's been an earthquake swarm here for a while. There was a bit of a forecasting about the likelihood of this going off. It wasn't too much of a surprise to those who'd seen thousands of quakes happen, as well as ground deformation and so on. So you'll find spectacular footage all over the internet about this one and about the Iceland volcano also having upticked recently. And there you can see the locations of all of those, not all of them, but lots of those magmatic earthquakes. Again, some people got evacuated as a result of that one. Let's check the rest of the list here on volcanodiscovery.com. We don't want to fixate. So yeah, La Palma erupting, producing a 10,000-foot plume of ash now, so significant eruption there. Subanose Jima exploding, similarly sized ash plume there, 10,000 foot. Flight level 100. Semeru, flight level 130. It's a 13,000-foot ash plume over East Java as it explodes. Samisa Pochnoi in the Aleutian Islands has intensified its eruptive behavior here. 15,000-foot ash plume from it. Also, rewind. Also, sulfur dioxide gas emissions have increased. Aviation code red. Fuego. No longer detectable volcanic ash over Guatemala. It could be a cloudy day and the satellites may not see it. Sangay exploding. 20,000-foot ash plume over Ecuador. Revenador, 15,000-foot plume as it explodes in that same country. Sabancaya intermittent emissions are a reminder to not pole vault the caldera. But do visit our websites, smashamash.com, smashamash.com/smashteam. You can find a link on the homepage to that. Thanks to our Smash Team members. Today's featured merch product is Mansa and Mensa. Make Earth not suck again. It's up to you. Make America not suck again. It's up to you, Americans. And last but not least, Universum Liberate. Join the Galactic Federation Special Forces, folks. And now we're in the realm of magnetic data. Let's talk about the GOES magnetometer. It's in a pretty normal range here. Nothing to write home about. Although there is going to be an uptick in all kinds of things, as there are coronal holes rotating in and 3 sunspot groups. So, here's the heliospheric current sheet polarity. Here's the latest image. Earth is still in a South Pole current sheet, which is looking quite large here. Half of the current sheet is South Pole and half is North Pole, quite close to half and half at the moment. Keep in mind that data is 1 hour and 19 minutes old and can change with basically no warning. We're going to see some wild swings of magnetism going on here with so many coronal holes, which are so well defined, and sunspot groups. Anyway, there's the line of sight view of the same stuff. Solar magnetogram. Here's the sun's B field in blue. These blue potential field surface source lines are the sun's B field. The B field being the field that goes through the magnet. And you can see some large, well-defined South Pole-oriented coronal holes showing up there in red. Also some green coronal holes all the way down by the South Polar region. So we'll be keeping an eye on that. Also, when I say ion, the pun is intentional. Here are some ions. Iron ions. This is the sun at 193 angstroms from the SDO. And this is a great wavelength that's showing coronal holes and filaments. And there you can see those South Pole-oriented coronal holes. And again, 3, no less than 3 beta-class sunspot groups. Likelihood of solar flares has gone way up as a result of that. So solar flare watch, in effect. There are your sunspot groups, solar magnetogram, and flare probability computerized readout. And I differ from that a little bit occasionally, depending on how close to the limb sunspots are. The likelihood of major flares from 2871 is definitely there. And there's one happening once again while we record the show. Not quite a C-class flare, though. It just de-intensified here. That's the GOES X-ray flux, as measured by the GOES 16 and 17. 2 different wavelengths, long and short wave X-rays there. Solar flares. Now this would be coronal mass ejections, protons, and we don't see any spikes there. We're not expecting any, although major flares could cause sudden coronal mass ejections. So here's the real-time solar wind, which is pretty unremarkable over the past 24 hours. Current conditions are 10.2 protons per cubic centimeter for the density. Solar wind speed very low here, 312 kilometers per second. There's the KP index at 0. Only 0 or 1 for the past 24 hours there, so very low geomagnetism. And here's the magnetohydrodynamic pressure, at least as modeled by the Space Weather Modeling Framework, which uses lots of data points and reasonable math to give us a likely model of what's going on in the geospace. It's Earth's geomagnetic field, folks. It gives you insight where the geomagnetic poles are located, for example. Anyway, it's 4 hours of data, and like the solar wind, pretty unremarkable here for the last 4 hours. Next, we'll look at ground magnetic perturbations, changes to the Earth B field, known as geospace delta B. So there we do see some perturbations there, especially around Antarctica, south of the Indian Ocean. Not major ones, as there's not a whole lot of induced magnetism from incoming solar protons. Continuing on, here's where stuff is in the solar system, and it looks like we're in werewolf mode here. The three nights surrounding the full moon, folks. So 3 nights surrounding the full moon. Watch out for zombie cannibals walking around expecting you to, I don't know, wear a mask. By the way, there's where things are now. Let's advance it a week. And I think tomorrow is the official full moon. There's where things will be on the 27th. We also show a star chart daily for all of our spaced out viewers. The moon's just about to set here in Lehigh Valley. We've drawn in the galactic plane and the ecliptic plane on our star chart. And we're going to do a brief cosmology segment once again today. These aren't always integrated into the daily space weather video, but today's was, because we wanted to keep it a little bit on the short side. So let's do it. We're going to pick a random number. We're going to go to the Neil Gehrels Swift Bat X-ray Observatory. Here's 827. And if you go to the Neil Gehrels Swift Observatory, if you click on Bat Transient Light Curves right there, that little link right there, you see that, folks? Click on that. It'll take you to the light curves. There are 1,050 of them, which is why our random number generator picks a number between 1 and 1,050. Now again, today's is 827, which coincides with a blazar, which is, I think, my favorite cosmological object. Yes, it's PKS 1830-211. Not that bad of a name considering the naming conventions for blazars. And it's pretty cyclical here. See, it's got pretty regular spikes and troughs. Now, if you click on Simbad, it's going to take you to the Simbad website. Surprise, surprise. And from there, you can click on the CDS portal. And this is the one that everybody wants. The CDS portal, showing you crazy amounts of information about the blazar. So put in your favorite object. This one's also known as Quasar B 1830-211. It's almost like squares and rhombuses, folks. You know that all squares are rhombuses, but rhombuses aren't necessarily squares. Did you know this? Well, blazars, quasars, similar. Anyway, it's showing you where the bright spots are in terms of this object, and you can see it's pretty full spectrum there. And it's got bibliographies here, tons of different information here, all in chronological order, going all the way back to 1984, 1983. As they were studying high polarization quasars. Yes, back in 1983 and even in 1993, nobody really knew what a quasar was, at least not commonly. Most people didn't know what it was. Now we know it's just based on orientation, folks. Yes. So let's take a look at some visual analysis here. We'll just look at the CDS featured here real quick. How about some false color X-ray imagery? There's that blazar. And you're looking directly down the polar jet of a galaxy here, which is why it looks so bright. There is possible cosmic ray source right there before your very eyes. How about pan-stars? There's the G band. You can see how dark it is in optical light. Let's see if she shows up on the 2-mass. And there is, you can see a little spot there. There is a sort of a thermal signal from it. It's sort of a cool spot. And we'll close out on the Fermi gamma ray. It looks like it's a pretty bright gamma ray spot, folks. And really not that much of a surprise. That's probably giving us insight into the shape of the jet from this blazar, and you can see how bright of a gamma ray source that is. One of the brighter ones in the entire sky there. Today's featured random, quote, random, end quote, object, PKS 1830-211 on the Neil Gehrels, also known as Quasar B 1830-211. We've got Herbig-Haro objects as well in the cosmology segment for today. It's the astronomy picture of the day from apod.nasa.gov. Go check it out yourself if you like. Herbig-Haro objects are believed to be star birthing areas, areas where there are all kinds of jets and interesting filamentary gaseous features, dust, and so on around the star. You can read all about that. There are links there to Herbig-Haro objects and the Cepheus flare region. There's all kinds of papers about it. Here's another one of these. This is the Cepheus flare region, I believe. And you can see these extremely well-defined columnar bipolar jets coming out of a sort of a dark region where the star is encased in a very dense cloud of nebular gas and dust. Very, very well-defined jets there. A bunch of protons losing a bunch of energy. You can also find this paper. It's also linked in there somewhere. Star-forming regions in Cepheus. It's 104 pages long. And it's quite in-depth here. It's from 2008. Go have a read if you like. That's today's cosmology segment. Let's continue on with the daily space weather to look at charging hazards, or the lack thereof, which is what we see now. Here's a one-year chart of the relativistic electrons from Earth's inner Van Allen belt. And here is the 3-day chart as measured by the GOES 16 and 17. Nothing to write home about there on remarkable electron flux. Here's the forecast. Expecting an uptick here in a couple of days, and I would tend to disagree with this. This is going to be lower because there is a CME headed our way, which maybe everybody's missed it. I don't know why, but anyway. There's a CME headed our way, folks, a coronal mass ejection. Here's a diagram of Earth's Van Allen belts, and we're going to show you the total electron content forecast next. Previous the previous frame showed distances in miles, and this is showing the electron content for the entire airspace between your GPS satellite and your handset. Things looking normal at the moment. Here's the ionosphere. Things looking a little bit abnormal at the moment. Some anomalies showing up in the ionosphere. The F layer is located at 300 kilometers of altitude, and here is where we're going to show you that slice in vibrational frequency. Excuse me. And we're seeing some low-frequency anomalies here in the northern hemisphere, primarily. Some pretty serious ones in the central Pacific Ocean. Here's the latest image. That's 9:45 Universal Time. Here's the anomaly map for those of you not used to looking at this one. This is anomaly in terms of departure from the 30-day median in megahertz. And it's showing you low-frequency anomalies in red, high-frequency anomalies in blue. There's a 6 megahertz variation there in the anomaly map, plus or minus 3 megahertz. Anyway, here's the latest image. That's 9:45 Universal Time. And by the way, if you don't check out our meteorology segments, check those out. They usually air before our daily space weather videos, the space weather. By the way, make sure you visit our websites, like smAsho.com. We're also on BitChute. Did you know that there are exclusive videos over there like this one? And like our 9/11 feature? Never forget, folks. Never forget. Forget what? To demand accountability. Follow us on Twitch also. We go live regularly. We just did it for our meteorology segment. Those usually premiere before the daily space weather. Did I already say that? Anyway, here's our YouTube promo advertisement. Cheers. Thanks everybody who tuned in on YouTube. It's the main source of our content. Press like, press subscribe, tell your friends, tell your foes. Check our playlists. There are all kinds of videos there you may not have seen. Thanks to our patrons for making the Smash team possible. Please come join the Smash team. Join before October. By the way, the Smash team bills on the date of enrollment. It doesn't care about what the date is like Patreon does. One of the many advantages to the Smash team. Also, you may see things like this that you won't see otherwise. And we're just showing you here. By the way, for all of you who've signed up at Smash Team, the way to use this is to click on posts. When you click on posts after you're logged in, you will see all the posts that you have access to. So whether you're at the bronze level, or the silver level, or the gold level, or the paid up annual subscription gold level, you may see different things. You may get sudden updates and disaster reports and all kinds of other stuff depending on what your level is. You can find links to it at smAsho.com. Welcome to the Neo Renaissance. Congratulations on finding our channel. Universum Libertate. Today's featured products are the Mansa and the Mensa. So I've got a Mensa hat on right now. It says Mensa. Make Earth not suck again. See that? There you go. Mensa. Make Earth not suck again. It's up to you. The other featured product is Mansa. Make America not suck again. It's up to you, Americans. It's up to you. Not ineffective bureaucracies that can't even get out of their own way, much less give you medical advice. Let's take a look at some bonus features here, such as the latest hydrogen alpha imagery here from El Teide, Spain. And we've actually got a CME, I think, captured once again here. It looks like this filament is now gone, and it may be headed in our direction. It's too early to see, but there could have been a CME there. We just captured it. This data only 2 minutes and 21 seconds old when we recorded the video. Here's your latest intensity gram. So there's that sunspot group. It's beta class. Here's this sunspot group. It's also beta class, and it's grown since I last looked at it. And here's this sunspot group. It's also grown since we last looked at it. Here's the latest refresh of the fields. There's 2871. It's quite interesting. Again, also beta class and also beta class. So another precipitous uptick. Let's take a look at the view from Lagrange point 5 and Lagrange point 1 here real quick. So on the left, you've got Lagrange point 5, that's stereo A, located here. On the right, you've got Lagrange point 1 with some ancient data here. Some ancient data that are showing up on the LASCO C2. Let's see if we've got anything newer than that. So that's fairly up-to-date data, but on stereo A, it's like 10 hours old by the time we made the video. Anyway, here's some more solar imagery to close things out. Here's 94 angstroms. It'll show you all the brightness associated with these 3 sunspot groups. Some great imagery there. And here's 131 angstroms, another one of the ultraviolet wavelengths of ionized iron. Thanks for tuning in, folks. Remember, stare at the sun. Use our channel to do so. Check out our playlists. There are all kinds of spectacular playlists on there that you may not have seen. Go watch the videos. And may that solar wind be at your back.